নমস্কার। আমরা আজকে আমাদের পেজ হোম স্টাডি 24x7 এ আবার চলে এসেছি। আজকে আমাদের টপিক হচ্ছে পেডিগ্রি অ্যানালাইসিস। পেডিগ্রি পেডিগ্রি জিনিসটা কি? পেডিগ্রি অ্যাকচুয়াল is a tubular representation of a family history by taking a particular disease or character into consideration. If there is any disease occurred in any generation or any in a family history, then pedigree analysis can be placed. Actually, pedigree is very much helpful to consider the disease as genetic or non-genetic. Okay, at first we have to identify some sorry আইডেন্টিফাই সাম সিম্বল। আমাদের কিছু সিম্বল নিয়ে আমাদের আগে জানতে হবে। তার আগে আমাদের জানতে হবে যে হোয়াট ইজ বডি সেল অ্যান্ড হোয়াট ইজ সেক্স সেল। দ্যাট ইজ যে আমাদের বডিতে যে ক্রোমোজোম, সেটা হচ্ছে 23 পেয়ার্স অফ ক্রোমোজোম থাকে। অর্থাৎ তার মধ্যে দুটো থাকে, 44টা হচ্ছে অটোসোম, দুটো হচ্ছে সেক্স ক্রোমোজোম, যেটা মেয়েদের ক্ষেত্রে এক্স এক্স এবং ছেলেদের ক্ষেত্রে এক্স ওয়াই। এবার ব্যাপার হচ্ছে যে এই যে সিম্বলগুলো, এবার কোনো রোগ সেটা যদি দেহকোষ জাতীয় হয় তাহলে সেটাকে আমরা অটোসোমাল বলবো, যদি সেটা এক্স বা ওয়াই ক্রোমোজোম গঠিত হয় তাহলে আমরা সেক্স লিঙ্ক বলবো। এই পেডিগ্রি বুঝতে গেলে প্রথমে আমাদের কিছু সিম্বল সম্পর্কে জানতে হবে। আমি খুব ভালো করে তোমাদের সিম্বল খুব ভালো করে তোমরা দেখো। ফার্স্ট সিম্বল স্কোয়ার উইদাউট এনি ফিলিং, ফাঁকা স্কোয়ার, তাকে আমরা মেল দেখাবো। একটা সার্কেল যেটা কোনো রকম কোনো ভরাট করা নেই, অর্থাৎ empty just circle, this is female. Now the square and circle, if that are filled with black, or if that are filled, then it is called affected individual. If we connect male and female with a line, then it shows marriage or mating. Okay, now it is one generation and two generation. If we consider a male marry with female, then the line, and from this couple two offspring are found. Okay, now these are identical twin and non-identical twins. So we saw that square means male, circle means female. Square, if square is filled, then it is affected male. If square is filled, if circles are filled, then it is called affected female. And this is called mating. This is father and mother, and they are the child. Okay, I think you understand the symbol. Okay, used in pedigree. At first we have many consideration to understand the which type of disease is it. Is it autosomal disease or sex-linked disease? Is it dominant disease or recessive disease? We have to understand, and we have to make solution seeing the pedigree about the disease. So at first we have consideration that first we look of mitochondrial inheritance. You have to know that in any cell, nucleus is the head office, as it has chromosome. Okay, and chromosome means DNA. But instead of nucleus, in mitochondria also DNA or mitochondrial DNA or mitochondrial gene can be present, and this mitochondrial gene or mitochondrial gene is carried out from mother to offspring, অর্থাৎ মায়ের থেকে সন্তানের কিন্তু মাইটোকন্ড্রিয়াল যে ইনহেরিটেন্স, জেনেটিক ফিচার্সগুলো ফ্রম মাদার টু অফস্প্রিং সেটা ক্যারি করা হয়, সেটা যায়। অ্যান্ড So in any pedigree, if we see the all the disease, just like you see that, okay, now this is a pedigree. Okay, at first in pedigree we consider this is one generation, this is second generation, and this is third generation. Now this is male and this is female, and I say that if any circle or square are filled with field, then it is affected. Here male is not affected but female is affected. Okay, so female is affected, and from female there are, from this couple, 1, 2, 3, 4, and 5. 5 offspring are produced. Okay, and these are not offspring. Sorry, these are not offspring because they marriage with this guy. Okay, so these 1, 2, 3, 4, 5 are offspring, and all the offspring are affected. Okay, all the offsprings are affected. Now, from this affected second generation, from this affected male, no one is affected. From the affected female, everyone is affected. Every offspring. From this affected male, no one is affected. So, if we see that disease transmitted through female or through mother, then it is called mitochondrial inheritance. So at first we have to consideration if the pedigree is bearing mitochondrial inheritance disease or any other. If we consider the female, okay, this female is affected, and every offspring are affected. Okay, but in case of male, nobody is affected. In case of male, nobody is affected. In case of male, sorry, in case of female affected. In case of male, nobody is affected. When this is transmitted only through mother or only through female, then it is called mitochondrial inheritance. So at first we have to look that is it mitochondrial inheritance. If no, then we'll go to second. Look if the gene is dominant or recessive. Oh, this is a very important thing. We have to understand that dominant means in all generation disease are caused in all generation. There is no skip of generation, and in recessive inheritance skip of generation is occurred. So in dominant, the main point, skip of generation. No skip of generation. But in recessive inheritance, skip of generation can be seen. Okay, these are the two things we have to understand. So at first, we have to understand is it mitochondrial inheritance or not. Then we have to understand is it dominant or recessive. Okay, so how we understand dominant or recessive? Okay, you see, from this pedigree, say this, it has 3 generation. This blue color seems the affected individual, and now you see that this is affected individual. Its parents, one of his parents affected, one of his parents affected. Okay, now this affected one, his parent affected, one of his parents, and one of his parents affected. This individual, his parents affected, his parents affected. This individual, his parents affected. So, if we see that in every generation, any of the parents are affected and no skip of generation can be seen, then it is called dominant. I hope you understand. Okay. But in case of, you see that, sorry, uh, uh, okay, if you see that recessive, these are affected, but there is no affected individual in their parents. So if skip of generation occurred, then we will call the pedigree is recessive. So at first we have to consider that what is dominant and what is recessive disease. Okay, These are the point you can understand. At least one member of all generation will have the disease. Both affected parents can produce normal offspring. Parents must be heterozygous. Recessive inheritance, there will be some generation without the disease also, that is skips of generation. Both normal parents can produce affected springs. In such cases, parent must be heterozygous. So now first consideration is mitochondrial inheritance. Second consideration is it dominant or recessive? Now autosomal dominant disease. Okay, we have to just, it is very common thing that if the affected number of or ratio of affected individual, affected male and affected female is most probably almost same, 1:1 or 1:2 or 1:3, almost very near, almost equal, no sex predilection if occurred, then it is called autosomal. Okay, so you can see that in this case, one male, one male, one male, or three males are affected, but female, one, two, three, four, then three male, four female. So it is quite three male, four female. This is some difference of one person. So it is can be considered as autosomal. Okay, but we have to sanguine for, is it autosomal or dominant or autosomal recessive or sex-linked dominant or sex-linked recessive. So at first we have considered that what is it, dominant or recessive. Then we have to sanguine it. Okay, so here is some points that no sex predilection is happened. So there is no sex predilection. Almost equal number of males and equal number of females are affected in this case. Now, affected individual transmit disease to half of offspring. Affected individuals transmit disease to half of offspring. If affected individual have two offspring, then one will be affected and other will be not affected. So affected individual transmit disease to half of offspring. Now, one of the parents of the offspring, one of the parents of the affected child should be affected. So if we consider that this is male, this is female, now these are the offspring, these are the offspring, and here this is affected, this is affected. So one of children should be affected if any of parents are affected. So one is equal number of male and female, and second is affected individual transmit half of the affected offspring, and one of the parents if affected, children should be affected. Okay, no children no children of normal parents will be affected. No children of normal parents will be affected. If parents are normal, offspring cannot be affected. If parents are normal, offspring cannot be affected. Okay, now normal child can be produced from affected parents. These are the main thing you have to understand. You have to memorize that normal child can be produced from affected parents. So if we see affected parents, normal child can be seen. So if normal child have affected parents, then it is called autosomal dominant disease. Okay, and the examples are Huntington disease and nail pellet syndrome. So in Bengali I am translated that এখানে দুটো মেল আর ফিমেল ইকুয়ালি অ্যাফেক্টেড হবে। সেকেন্ড পয়েন্ট, ডিজিজ ট্রান্সমিটেড হবে হাফ অফ দ্য অফস্প্রিংয়ে, যদি দুজন ছেলে মেয়ে থাকে একজনের হবে একজনের হবে না। ওয়ান অফ দ্য প্যারেন্টস অফ দ্য অ্যাফেক্টেড চাইল্ড শুড বি অ্যাফেক্টেড, যে কোনো একজন প্যারেন্টস অফ দ্য অ্যাফেক্টেড চাইল্ড শুড বি অ্যাফেক্টেড হতে হবে। নো চিলড্রেন অফ নর্মাল প্যারেন্টস, নর্মাল মানে প্যারেন্টসের কোনো অফস্প্রিং অ্যাফেক্টেড হতে পারে না। নর্মাল চাইল্ডের বাবা মা কিন্তু অ্যাফেক্টেড হতেই পারে। সো দিস আর দ্য কনসিডারেশন। Now, the pedigree. At first, from this pedigree, we have to understand if is it mitochondrial inheritance or not. Male also transmit disease, so it is not mitochondrial inheritance. Okay. Now I have to consider that affected, parents affected, parents affected, 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 affected. So these are the dominant. Okay. Now you see that there is 3:4 ratio, 3 and 4, one person is depicted. So it is autosomal dominant, but we have to sanguine it. Then we have to consider that you see that you see it unaffected, normal, normal baby, normal offspring, but its parent is affected. So we understood that it is autosomal normal. We have affected parents, affected one of the affected parents, and similarly it has 5 children, and 3 are affected, 2 are not affected, so almost equally half. This affected half of, or 2 children only 1 is affected. Okay, so these are the consideration we have to understand to where is it autosomal dominant or autosomal recessive. Now autosomal recessive disease, again no sex predilection. We have to see the skip of generation. If skip of generation occurs, then it is recessive disease. Trait often skip of generation, but equal number autosomal. We know that equal number of male and equal number of affected female are present. Affected individuals transmit disease 1/4 of offspring. If 4 offspring are produced, then 1 will be affected in case of autosomal recessive disease. If both parents are affected, the offspring should be affected. Both parents affected হলে offspring কিন্তু affected হবেই. And one of its consideration is if offspring is affected, parents are not affected, it also be happened. মানে আমরা অটোসোমাল ডমিনেন্টে পুরো উল্টো জিনিসটা দেখছি। যদি অটোসোমাল রিসেসিভে ক্ষেত্রে কি যদি সন্তান অ্যাফেক্টেড হয়, অফস্প্রিং অ্যাফেক্টেড হয়, তাহলে বাবা মা অ্যাফেক্টেড নাও হতে পারে। আর অটোসোমাল ডমিনেন্টের ক্ষেত্রে আমরা দেখেছিলাম সন্তান নর্মাল হতে পারে, অ্যাফেক্টেড প্যারেন্টস হতে পারে। তাহলে এখানে অটোসোমাল রিসেসিভের সন্তান কিন্তু অফস্প্রিং বা বেবি কিন্তু অ্যাফেক্টেড হলেও বাবা মা অ্যাফেক্টেড নাও হতে পারে। And this can be happen in consanguineous marriage, or there is a genetically identical, অর্থাৎ নিজেদের পরিবারের মধ্যে যে বিয়ে তারা যদি করে, মাসির ছেলে মেয়ের সাথে, মামার ছেলে মেয়ের সাথে, নিজের পরিবারের মধ্যে যদি বিয়ে করে, this is called consanguineous marriage. Okay, if the relationship occurred in same family. If a normal person is married to an affected individual, one or more of the children is affected. Okay, so these are the phenylketonuria and thalassemia. So we have the consideration 2, that is 1/4 of the babies are affected. Okay, and number 2, if it can happen that baby are affected but parents are normal. Okay, now this is some example. Okay, now third look, if the disease is X-linked or Y-linked. If it is not autosomal, then it can be X-linked or Y-linked. In case of sex-linked dominant disease, these have sex biasness, and in case of dominant, we know not skip of generation, and it will be consideration that affected males must come from affected mother. Ma affected hole, we know that in family it can be happen that mother has fond of love to her son, and father has a lot of love to his daughter. So this is some genetically that is consideration that in case of disease also, disease can be transmitted from mother to son and from uh, father to daughter. So the main consideration is this point, that all the daughters, if are affected, then father should be affected. It is the main consideration to know if is it X-linked dominant or X-linked recessive. So at first this is obvious that skip of generation can be happened. Affected male must come from affected mother. Sex biasness can be present, but the main point we have to understand that all the daughters, but none of the son of an affected father are affected. If father is affected, her daughter will be affected, not his son. This is the main consideration. If father is affected, daughter is affected, not son. This is the main consideration. Beside this is X-linked autosomal. So see the pedigree. See the pedigree. That. Okay. At first, dominant or recessive. So this is affected, 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 affected. Its parents also affected. One of the parents affected and affected. So there is no skip of generation. So it is dominant disease. Okay. Now we have to consider that male 1, 2, 3, 4, and female 1, 2, 3, 4, 5, 6, 7, 8, 9. It is obvious sex linked dominant, but we have to sanguine. How we have to sanguine? So you see that. You see father is affected. Okay, all the daughter is affected, not any son is affected. If father affected, daughter will be affected, not son. Here also father affected, son a daughter affected, not son. Here also father affected, daughter affected, not son. So it is X-linked dominant. These are the X-linked list of X-linked dominant disease. Okay, these are the main disease you can see. Okay, now X-linked recessive. If the main consideration is that if this is not sex-linked dominant, then obviously it's recessive. Skip of generation, and most of the affected individuals are male. This is the main consideration of the sex-linked recessive disease, that most of the males are affected, not female. This is the main consideration. Males, okay, and these are the rather part, but it is the main consideration. And if this is not okay, not sex linked dominant, then it will be sex linked recessive. So all of the sons of an affected mother must be affected, all of the son. For a male child to be affected, the mother must be affected or a carrier. This is the main problem that we have. We have some difficulties in this point, that because mother has two X chromosome. If one X chromosome is disease prone, the other X chromosome must on it. So it is difficult to show the disease. It can be carrier also. So it is, but in case of male, there is X or and Y chromosome. If the disease is a disease born with X chromosome, then it will be appear. If Y chromosome, it will be appear. But in case of mother, it can be. In case of female, it can be carrier. So it is hard to consideration. So if it is the elimination problem to consider, is it sex-linked recessive or not? Is it sex-linked? Is it dominant or recessive? Then we consider, is it happen that father affected but not daughter affected, son affected? Is it happen? If it's happen, then it is sex-linked recessive. Okay, this is the phenomenon. Unaffected father and carrier mother, they are cross and form unaffected son, unaffected daughter, carrier daughter, affected son. Okay. These are the X-linked recessive disorder. You can understand some disease. Now, if it's happened that there is never skip of generation and only males are affected, then it will be Y-linked or Holland disease, not X-linked or sex-linked disease. If only males are affected, then we will shut our eyes and we will write that it is Y-linked or Holland disease. So these are the gist that we understood from this chapter. That is, consider these. At first, is it dominant or recessive? Is it mitochondrial inheritance or not? Not mitochondrial, not Y-linked, because female also be affected, also affected. So first consideration, this is first generation, this is second generation. Now this is affected and also affected. No skip of generation, then it is dominant. And now not normal daughter but affected parents. If offspring is normal but parents can be affected, if it happen, then it will be autosomal dominant. Okay, now autosomal recessive. Okay, how will we understand that this is the affected child but mothers and parents are not affected, then it is autosomal recessive, and there is we see that skip of generation will happen. Now, X-linked dominant. What is the main cause? X-linked dominance. Father is affected, all daughters are affected, and there is not a equal amount of this can be sex biasness. Okay, there is X-linked dominant and X-linked recessive. X-linked recessive. Most males are affected. So these are the consideration how we can understand without any analysis by just watching it the video. Now some examples. I think there are 5 examples for you. So you have to answer it and comment me the answer that you have solution, and I will be all. And first I just help in first case, not in all case. Okay, this is the first generation, this is the fourth generation. First we consider that is dominant or recessive. So first consider that is male are affected. No. If all males are affected, yes, males are affected. So it can be Y linked. Okay. But and you see that never skips generation. But here skip of generation happen. Skip of generation happens. So it is not Y linked. If you consider skip of generation, so it is recessive. And most of the male are affected. I think it is X-linked recessive. Okay. Now this is second. Am I right or wrong? Or you have to answer? You have to answer. And I will be saluted after some days in next video. I will be see in next video with the solution of these examples. Okay. This is second. This is third. This is fourth. This is fifth. So you have to complete the pedigree, and we will in next class we'll hear for solution of these questions. I may be wrong. You have to understand. Okay. by watching it. So this is a preliminary idea of pedigree analysis. But first, so this is pedigree. This is a symbol, mitochondrial inheritance. Okay, you can see. I think you can understand. Okay. So these are the questions. First question, second question, third, fourth, and thank you the students, all the students. আমাদের পেজ হোম স্টাডি 24/7 তোমরা যুক্ত থেকো, সাবস্ক্রাইব করো, লাইক করো, শেয়ার করো, আর অবশ্যই আমার হোম টাস্কগুলো কিন্তু করে ফেলবে, এবং আমরা নেক্সট ক্লাসে কিন্তু এই সলিউশন নিয়ে হাজির হব। সো ততদিন পর্যন্ত অল দ্য বেস্ট। আবার আমরা আরও নতুন নতুন ভিডিও নিয়ে আসবো। আশা করি তোমরা পেডিগ্রি প্রিলিমিনারি আইডিয়া তোমাদের ক্লিয়ার হয়েছে, বাট পেডিগ্রি কিন্তু আরও কিছু বাকি আছে, যেটা আমরা নেক্সট ক্লাসে cover up করব। Thank you student, thank you very much. Stay home and stay safe.